So in the previous couple of examples, we saw some cases where we wanted to take a ring of this form S adjoin A, and we wanted to simplify it some way. So what we wanted to do is figure out what do the elements look like. And when we did some examples of this, like for example, we worked through Q adjoin root 2, and we decided that even though we were allowed to take any powers of root 2 that we wanted, all we needed were 2 of them. We could write everything we needed as a plus b root 2. And we decided that because we knew things here simplified, because we knew that we could write something like 3 plus 2 root 2 plus 7 root 2 squared as 17 plus 2 root 2. If we simplify, if we clean up that 7 times root 2 squared and make it 7 times 2, then we can clean this up and write it in this form a plus b root 2, and we could do that with whatever power of root 2 we wanted. We'd be able to sort of reduce it down to just an a plus b root 2. So one question that's lingering here is how do we know, when do we know that we can do this, and how do we know when we're done simplifying? So this example is one we know a lot about. We know how root 2 works, but what if it was something more complicated? And so we're going to think through this process of how do we know when we can write something differently. So how do we know when we can rewrite an expression in a different way? And we're going to take that question and frame it as how do we know, or when can we write 0 in a different way? All right, so what I mean by this, of reframing it into this question about 0, is if we look at that example just up above, that 3 plus 2 root 2 plus 7 root 2 squared, I decided I could write that differently, and another way to say the same thing is that I was able to make an equation that equaled 0 with two that look different from each other. And if I combine like terms here, so I have my 3 and I have my minus 17, so that's a negative 14 together. I have a 2 root 2 and a minus 2 root 2, so that's no root 2's. And then I have a 7 root 2 squared. And so what I'm saying in this example is that I can write this expression equal to 0 in a way that doesn't look like 0 immediately, right? Since we know a lot about how root 2 works, we know that this is 0, but it sure doesn't look like 0. It has this 14 in it, negative 14 in it, and a 7 in it, and that's a little bit bizarre. So we want 0 to be 0 and 0 a's and 0 a squareds all the way up to whatever power you want. You want all these 0 coefficients. And my example above, I have an expression with powers of root 2. There's where my a is root 2, but I don't have all 0 coefficients. And that's because of how root 2 behaves. Okay? So in general, what we're wondering is if we can write 0 as some s0, s1a, dot, 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 up to sn a to the n, where the s coefficients are not all 0. Okay? Because the idea is if we can do that, then we know we have some kind of duplication of our elements. We know we have some kind of repetitive way of writing things, and we haven't simplified as much as we can. So if we can still simplify how we describe S adjoin A. Okay, so if we can write 0 in a way that doesn't look like 0, meaning all 0 coefficients, then it means we can simplify S adjoin A. All right, so let's take an example of that Q adjoin root 2 again. So can we write 0 in a strange way? Okay, and answer right off the bat is yes, just like I did up above, right? That negative 14 plus 7 times root 2 squared is 0. And what this means is we can simplify how we write our elements. We don't need to use root 2 squared. All right, so if we write everything as a plus b root 2, can we still simplify? So we know the answer to this is no. I think intuitively we know that, but we want to see how we would actually prove something like that. So I would take something like, suppose a plus b root 2 is 0, where a and b are rational and are not both 0. And I want to say, no, I can't do that. The only way I can write 0 is if a equals 0 and b equals 0. All right, so how will we do this? So we're going to think about if a plus b root 2 is 0, then b root 2 is minus a. So I'm just going to subtract a to both sides. And then if b is 0, then 0 root 2 equals minus a, so a is also 0. Okay, need a new page. So we knew that b root 2 is minus a, and if b is 0, then a is also 0. But we didn't want that, right? We said a and b are not both 0. So that means we can assume b is not 0. So root 2 is minus a over b. Because b is not 0, I'm allowed to divide by it. And so I take that equation, b root 2 equals minus a, and I divide by b. So I get that root 2 is minus a plus b. Okay. Now, this means root 2 is rational, since minus a over b is rational. And this is a contradiction. All right, so if root 2 is minus a over b, then root 2 is rational, and we know that root 2 is not rational, and I'll post some links to proofs where you can see that. But we get this contradiction, and so that means something that we assumed had to be false. So we go back up and look at where we were. So we were supposing a plus b root 2 is 0, a and b are rational and are not both 0. The thing that we're going to say is false is that not both 0 part. We still want a plus b root 2 to equal 0. We still want a and b to be rational because that's the setting that we live in with q adjoin root 2. And so the assumption that must have been false was that both are not 0. Okay, so therefore A and B must both be 0. And so saying that means that we've simplified as much as we possibly can. We didn't find any other duplication like we did with root 2 squared up here. And so that means our q adjoin root 2, we can write it as a plus b root 2, where a and b are rational, and that this is the best way to write this set. So it's the simplest way to describe this set. All right, so part of your homework will be doing some little computations like this, trying to show that the only way to write 0 is with all 0 coefficients. And that feels a little bit of a strange thing to do right now, but it will come into play later and make a little bit more sense there, or we'll see it in a slightly different context. For now, we're thinking about this as a way to avoid duplication, a way to make sure that we're writing things in the best way we can and that we're not using expression root 2 squared that we really don't need to use.